The TFT of a finite endpoint sequence is a sampled version of the TTFT. So we can express xk with the sampled the frequency instead of omega hat. It will be sampled as omega hat k, which is 2 pi over n k with the same spacing. So here will be xj 2 pi over n k for k is 0 to n minus 1. Since the DTFT is always periodic with a period, DFT is also periodic. Let's consider omega k plus 2 pi. So 2 pi is 2 pi times 1 and 2 pi n over n. So we combined and extract 2 pi over n, then it will be 2 pi over n times k plus n. So instead of k, here is n plus k. So we consider this instead of k, we put k plus n. It means that xk plus n. So it's period that with a period n. Okay. When you remind our DTFT, we consider a fundamental period from minus pi to pi instead of 0 to 2 pi. Since it is periodic with period 2 pi, if there is signal like this, will be the same. What about the negative frequency of the DFT? x0 is xn, x1 is xn plus 1, x2 is xn plus 2, blah blah blah. What about x minus 1? It will be same as x minus 1. X minus 2 means xn minus 2. So x minus 1 is same as xn minus 1. It is xn minus 2 like this. Okay. Since we consider the number from k is 0 to n minus 1, you can also consider the periodic principle of frequency regions from minus something to something. Okay. When we have a real signal, then there is conjugate symmetry in the DTFT. So, similar to DTFT, the DFT coefficients must also satisfy the following property. Here, xn minus k means xn minus k0 means x minus k0 is periodic property. So when you put this minus k, so DTFT, then it will be minus j. It means that instead of j, we put minus j. So here, like this. So here's negative frequency x minus k0 will be xk0 complex conjugate when xn is real signal. when we have L point signals time domain, but we want more samples in frequency domain to get a fine spacing. What can I do? There's a very tricky scheme called zero padding. Means that here is we have HM is like this, only 3. Instead of 3-point DFT, we can have 6-point DFT with 3 zero paddings. So here is from L minus 1, L, N. For larger N, then we have the same value of original HN signal as HGP, and from N is L to N minus 1 it will be 0. Just put 0. So we call zero padding. Then what can you do in DFT? So we can put the definition, and N is 0 to N minus 1 sigma HGPN exponential minus J 2 pi over N Kn. Since here from L to N minus 1 is 0, when you divide the two regions, and the second one from L to N minus 1 will be 0 because HGPN is 0. So Hn will be exponential minus J 2 pi N Kn. So when we have L a point DFT, it will be exponential J 2 pi L over Kn. In the case of N point DFT with zero padding, so when you compare 2 pi over L and 2 pi over N, it will be 2 pi over N is smaller than 2 pi over L because N is greater than L. Okay, so the spacing is finer. In special case, N is 2L and GP 2L is the same as the original one, HL. For example, 2 pi over N times 10, since N is 2L, so we can cancel out 5. It is 2 pi over L, 5. So it means that kth samples for L point DFT. In the case of even number, it will be same as the L. What about K is 2L plus 1? Odd number, odd 1. Then same way, 2 pi over N times 7. Then it will be cancelled out like this. Yeah, like instead of cancel out, L 2 pi to 7, this is 3.5. So it is in the middle of L. So we call it interpolation. For example, here DFT as this. If it's a sample L3 like this and this, if we have L 2 times, then in the middle we can have more finer value like this. But anyway, what happens when n goes to infinite? Then finer and finer, it will be continuous. Okay. So here is an example, and the original one was something like this. So we have 8 point running some filter, but we want 80 TFT. So when we have only 8 point, the value will be only this and this, and this. But using finer sampling in frequency domain, it is more data and spacing like this, because when L is L8, it will be 2 pi over L k. K is from 0 to 7. So it is 8, 4. So 0, 4, pi over 4, 2 pi over 4, 3 pi over 4, up to 7 pi over 4. So here 0 and pi over 4, 2 pi over 4, something like this. So when have 10 times of sampling, we have 10 times of more finers, but every L, 1 over 10th, it has the same value of the original one. So let's consider the periodicity of inverse DFT. What, instead of n, we put n plus n, capital N. Then the inverse DFT will be 1 of n sigma xk exponential j 2 pi over nk n, but we put n plus 1 instead of n. So here we can 2 pi over nk plus 2 pi over n times n, cancel out 2. K. Since k is 0, 1, 2, 3, 4, 5 up to n minus 1, so it is always a multiple of 2 pi. So exponential of j 2 pi k will be always 1. So we have the same number n, so it will be xn. So inverse of DFT will be periodic. This is the sampling theorem of DTFT. So considering the data xt2 xn, then xj omega equals to x is going to j omega hat, right? So this is periodic with 2 pi. Similar to here is the sampling. So sampled xk, then goes to time x and tilde, it will be periodic with n, like this. So right there. Okay, let's consider an example. We know that the TFT has a delay property as follows. If time domain is delayed by nd, then in frequency domain there is multiplication of exponential j omega hat nd. Similarly, the TFT has a delay property. So here, if time delayed by nd, we can put here, and instead of omega hat, we can put omega k as a 2 pi k over n. So we will have 2 pi k over n. Okay, what will be time shift of the TFT? Xn, we have, if we have Xn and take a Fourier transform TTFT, it will be continuous and some periodic from minus pi to pi. It is like a something assume like this, and it is periodic 2 pi, but we consider only principal period, and this is like this, like that, but we consider only this area. If we take sampling and sampling, and sample like this, for example, here is 10, we have 10 sample, then inverse DFT, IDFT, it will be periodic with n, x tilde n, which is x n for n is 0 to 9, and also it will be periodic with n. So the original signal has these 10 samples, and after the DFT, and inverse DFT will be periodic. This one will be periodic like this, like this. If you want the original signal xn, then you consider only fundamental time from 0 to 9. What if time period is a shift like this? Then you will be move from here, then like this. So due to periodicity of DFT, it is circular shift. For example, in the case of x n minus 4, then it will be something like this. But due to periodicity, this one goes to here, so it looks like a circular. So we call it circular shift. And convolution property of the DFT is similar to DTFT. In the case of DTFT, convolution in time domain will be multiplication in frequency domain. So it is the same in the case of DFT, and here is a convolution in time domain, then it is multiplication in frequency domain. Here is a DFT pairs and properties. Here is a delta n, it will be 1, same as DTFT. If there is shift, then instead of exponential j, omega hat and d for TFT, then we can put omega hat is 2 pi over n k and d. It's the same like this. In the case of property, there's a periodic with n. The frequency domain also periodic with n. Linearity and conjugate is the same as DTFT. And when we compare to DTFT, the periodic will be DTFT will be 2 pi, but in frequency domain, DFT will have a periodic with n. The conjugate will be same, and the others like complex conjugate and conjugate symmetry if time domain is signal is real, like that.